Welcome to Tech Talks. Our admin edition today is focused on getting more out of Splunk with SmartStore. Tech Talks is a series of short webinars that are deep dives for technical practitioners. We value you, our customer, and want you to continue in your Splunk journey. Our experts help create these best practices, and we want to help leverage them in your daily role. I'm Anna Mensing, a Senior Product Marketing Manager for the Splunk platform, and I'm excited to share with you today information about Splunk SmartStore and introduce my colleague, Srinivas Boba.
Thank you, Anna. I'm Srinivas Boba, a Principal Product Manager for the Splunk platform, and I'm excited to share an overview and details of SmartStore.
Thanks, Srini. So today we're going to talk about how growing data volumes require significant financial investment in infrastructure and compute capacity, how Splunk SmartStore can help you get more from your infrastructure and compute capacity investment. We'll also take a look at the SmartStore and how it is managed from a Splunk admin perspective. And then we'll cover additional resources available to you to help take advantage of these capabilities in Splunk. Our team will be available for Q&A over the Q&A widget within your screen. And if you watch a recorded version of this webinar, please continue the conversation through the Tech Talk discussions in our Splunk community. So a challenge we are all familiar with is the growth in data storage needs. From the 90s to 2000s to today, the amount of data generated for business purposes that needs to be analyzed has exploded. This is one reason people turn to Splunk to analyze their data at scale. However, it is also a challenge for administrators of Splunk itself. How much of my company's exploding data can we feasibly store and analyze in Splunk, given the infrastructure and compute capacity investment needed to run it? You're all likely familiar with this deployment structure of Splunk. We have a bunch of indexers and a bunch of search heads. As the amount of data increases, typically you would add more and more indexers. And as the volume of data increases, whether you are increasing retention or ingest volumes, you typically keep on adding more indexers. But adding more indexers in response to data growth is expensive. And is the added compute capacity even being used? Based on our analysis at Splunk, 95% of Splunk searches are only over the last 7 days, and 98% are over the last 30 days. This means you do not necessarily need the added compute capacity of indexers added to address your storage problem. The added indexers are underutilized, so it is an inefficient utilization of the resources that you are adding to your Splunk deployment. Additionally, while the distributed scale-out architecture model with co-located compute and storage is a good model to process large volumes of data, this has not significantly evolved in the last 10 years since its inception to meet the needs of the growing data volumes of today. SmartStore addresses the issue of growing data volumes in Splunk. One of the key things that SmartStore brings to the table is that it decouples compute and storage. Now the majority of your data can sit in a remote cloud storage or on-prem object storage. And if you need to increase retention or amount of storage, you can always scale up your cloud or on-prem object storage separately. With compute and storage decoupled, all of the indexing or compute capacity you are adding to address your storage issues is no longer needed to scale your Splunk capabilities. That means you need fewer indexers. You need only as much compute to address the majority of your searches, say the last 30 days of data, that 98% of your searches. And if you need more performance, you can always add more compute. So if we take a look at Splunk's architecture with SmartStore, one of the key things it brings to the table is that it decouples compute and storage. Using SmartStore, you get storage cost savings from using lower cost remote cloud or on-prem object data storage and from a reduced indexer footprint. I'm going to hand things over to Srini to talk about how this works in more detail.
Thank you, Anna. Before we go deep dive on the architecture, let's take a quick look at the different states. Hot bucket is what we call the log file that is currently open for writing. Warm buckets is a read-only log files that are no longer written to. And then there is a cold bucket, data that has been tired out or moved past the warm edge. On the left side, you see the classic Splunk architecture, where the hot and warm buckets reside on the local storage of indexes, and the cold data moved to a cheaper commodity storage. On the right, you see the SmartStore architecture. As you can see here, the hot buckets reside on the local storage, similar to the classic architecture. But the difference is the warm buckets. The warm buckets are moved to a remote storage. And that is the big key difference between a classic architecture without SmartStore versus a SmartStore architecture. Essentially, what we are doing is that the remote object store becomes the location for master copies of warm buckets, while the indexer's local storage is used to cache copies of warm buckets currently participating in a search or that have a likelihood of participating in future search. Let's take a closer look at the SmartStore components. There is a search attire, and then there's the index attire with the local storage, and there's a new additional attire called the remote storage. The buckets here are represented in rectangle boxes, and the corresponding metadata is represented in oval boxes. Yeah, as you can see here, the key difference is the cache manager in the green box on each indexer. The cache manager on the indexer is the central to the SmartStore data flow. In general, there is no concept of cold bucket in SmartStore, but we can have cold buckets as part of the migration from non-SmartStore deployments. But both warm and cold buckets are treated the same in SmartStore. To summarize what Anna and I explained, with SmartStore, you are now able to scale compute and storage independently of one another at a lower cost. Let's take a look at high-level data flow with SmartStore architecture. The events flow to the indexers, that is written to hot buckets in local storage. In indexer cluster architecture model, these hot buckets are replicated to the peer indexes. There's no change in this model. When a hot bucket rolls to warm, a copy is moved to remote storage, and a copy is retained on the local storage. On the right side, you see how a search is executed with SmartStore. For most searches, it's identical to non-SmartStore architecture. Based on our analysis, 98% of searches involve data from the last 30 days. And the cache manager ensures recently created data and frequently searched data is readily available in local cache. And if there is a cache miss, buckets not available in a local cache, it is downloaded from the remote search. So one of the questions that comes frequently is like, what about the performance of the SmartStore? SmartStore works similar to the non-SmartStore architecture during the performance aspects. SmartStore cache is responsible for making sure recently used data and recently ingested data resides locally, close to the indexes. Additionally, it is an application and data-aware cache, meaning it is not necessarily going to pull data from the remote store, like the entire remote bucket. It will look at the search and see if the search requires metadata or Bloom filters to process that query. It doesn't need to download the entire raw journey file associated with the Splunk bucket. If the search query can be processed with, say, only metadata files, it will only download the necessary data to process your search. When we look at the data from the cache and we look at how recently the data was ingested and accessed, and as admins, you can specify your critical indexes that you want to keep it in the cache for a longer period of time, giving the admins direct control. This makes sure your active data set is always available in local cache. When you do need to run a search on long-term data, SmartStore will fetch only the necessary data sets into your cache. Your search doesn't need to know whether a data set resides in a cache or a long-term storage. Additionally, SmartStore indexer architecture is stateless, with data safely backed up in the remote storage, accelerating recovery or migration efforts and making the management easier. Let's take a look at SmartStore architecture advantages. We have three big areas. First one is scalability and high availability. You can scale out compute based on the performance demands. Second is the TCO reduction, decoupled compute and storage. Warm and cold data can be in remote storage, and hot and recently accessed data on indexes, and longer data retention by independently scaling your storage. Essentially, it's a lower TCO with S3 and S3 API compliant object storage. Finally, simplified management, reduced indexer footprint, and faster node recovery. You can just have one copy and RF-1 metadata copies on warm and cold on indexers. Fewer indexers required with only one full copy of warm and cold. And it also helps with faster node recovery and data rebalance with the metadata copy. The other key aspect is that this is application and data-aware cache. So you're bringing data on demand. Essentially, you fill up the indexer storage until available capacity, and when the cache is full, buckets are evicted based on the LRU, date age, and priority, and you load active data sets as needed. SmartStore comes with tools to monitor your deployment. The monitoring console provides really cool things about your SmartStore. These dashboards are available by default. Here you can see the connectivity to SmartStore and the activity. In the above screenshot, there is no activity going on currently. The other things you can see are how many buckets are uploaded, how many buckets are downloaded due to cache miss. Here the blue bar kind of represents the cache miss, representing the corresponding downloads from the remote storage. We have another dashboard on the monitoring console, which talks about the cache performance. We have a lot of metrics here, like how many buckets are evicted, what are my different settings for SmartStore, and tons of information regarding a SmartStore deployment. Finally, a monitoring console dashboard with cache hits and misses. As you can see here, the search overhead for the total search time due to cache misses. Essentially, when there's a cache miss, you need to download the bucket, and that search can result in a penalty for the overall search time. As you can see that on the orange on top part of the screenshot here. And second, you can also look at the cache hits and misses over time, which helps you give a overall visibility of the performance, how the SmartStore is doing. Let's take a look at the SmartStore in current production environments. 99% of Splunk cloud deployments are running on SmartStore in AWS and GCP. Starting in Splunk Enterprise 8.1, we have added support for GCP. We also have 100+ customers leveraging on-prem Splunk deployments with SmartStore. Following are the few codes from SmartStore customers. The customers are super excited and happy about the benefits of SmartStore, especially if you look at the third quote where they are no longer worried about running out of disk space for a long-term retention, which is key aspect of the SmartStore. To summarize the benefits of SmartStore, I'm going to hand it over to Anna.
Thanks so much, Srini. So SmartStore really allows you to achieve massive scale with lower infrastructure costs. And the benefits are that lower total cost of ownership, the performance at scale, faster failure recovery, and that on-demand clustering. So to get you up and running, we have several different resources that are available to learn more about Splunk SmartStore. So to quickly share the resources available to you to continue your journey, there are training and certifications on Splunk SmartStore that explore how the admin can implement this. There's also detailed documentation in Splunk Docs that will give you written step-by-step guidance on using this. There's also a myriad of .conf presentations and materials from past .conf where you can see this in action and watch really great detailed presentations. There's also several partner offerings around SmartStore, so we encourage you to learn more about those as well. So moving forward, how do we continue the conversation? The community.splunk.com webpage is a great resource as well. You can sign up or sign into our community and learn more about Splunk Answers, where you can search the tag SmartStore to view or share best practices. There's discussions where you can view the Splunk Tech Talk section, specifically for admins. And then there's also Splunk Ideas, where you can submit new product enhancements or vote for current ideas from other customers. So we really appreciate you taking the time out of your schedules to join us today for this Tech Talk. As a follow-up, you will receive these assets in another email, as well as the recording of this presentation, so don't worry about that. And please tune back in for future Tech Talks. We're excited to share the series with you.